So today we're doing section B of 2020 grade 12 past paper, and this question is based on a simple pendulum. The question there says figure B1.1 below shows a simple pendulum suspended from a fixed point. Fixed point. The bulb is slightly pulled to position A. So it's put to position A and then released. And of course, we know once it's released, it will swing to position B there. A says state one factor that does not affect the period of the pendulum. So we know that one of the factors which does not affect the period of the pendulum is mass, or we can say the size of the bulb. So regardless of the mass or the size of the bulb, it does not affect the period of the pendulum. Whether we use a bulb which is of small size, a big size, having more mass or less mass, it won't affect the period of the pendulum. Then we have another factor, amplitude. The amplitude, this is for small angles, does not affect the period of pendulum. So what do we mean by amplitude? So if you look at the diagram, if the bulb is not yet set in motion, the angle of displacement here, this part, is the amplitude. So like I said, for small angles, the amplitude does not affect the period of the pendulum. Okay, so for B, it says if the values of time for 20 oscillations obtained were 16.1 seconds, 15.9 seconds, 16.0 seconds, 16.2 seconds, and 15.8 seconds, calculate the period of the pendulum. Okay, so we know that period is given by time taken divided by the number of oscillations. Now the question is, which time are we going to use? So from the set of values of time, or for 20 oscillations, we can see that this experiment was actually repeated several times. It was repeated 5 times. So our T here, we need to find the average time. So how do you find the average time? We're going to add all the values of time and divide by 5. So meaning, for us to calculate the period, we'll calculate first the average time and divide the average time by the number of oscillation. So this gives us 16.1 plus 15.9 plus 16.0 plus we have also 16.2 plus 15.8 seconds divided by 5. Remember, this is the average. This is the average. Then we're going to divide this average by the number of oscillations, and we've been told that 20 oscillations. That's 20 oscillations. So that gives us the average of, we have 80 divided by 5, that gives us 16 seconds, which is the average, divided by the number of oscillations, which is 20. So we'll get the period to be 0.8 seconds. Remember, the SI units for period is seconds. So, like I said, if you have a set of values of time taken for a certain number of oscillations, it simply shows that the experiment was repeated, and for you to calculate the period, you need first to find the time, the average time. Once you find the average time, then you can go ahead and calculate the period. Average time divided by number of oscillations. Okay, you see, says calculate the frequency of the pendulum. Calculate the frequency of the pendulum. We know that frequency is given by 1 divided by the period, and we have already calculated our period, which is 0.8. so we have 1 divided by 0.8, which gives us, so 0.1 divided by 0.8, that gives us 1.25 hertz. Okay, or if you want to use this formula, another formula for calculating frequency equals the number of oscillations divided by the time taken. Number of oscillations divided by the time taken. So we are going to have 20 oscillations divided by time taken, and remember, we're using the average time taken, which is 16. So 20 divided by 16 still gives us 1.25 hertz. Okay, so that's how we handle this question, the simple pendulum. So from the topic for simple pendulum, which is under time, make sure that you know how to calculate period, and you also know how to calculate the frequency. Know factors that affect period of pendulum, and also know the factors which affect the frequency, length of the pendulum, and acceleration due to gravity.